Okay, class, we're doing section 1.5 today. The title for this section is Solving Inequalities, but before we get to those rules, we're just going to practice about writing intervals in interval notation. So here we have, for number 1, a couple of number lines with some intervals drawn on them. I'm going to show you also an alternate way that we've drawn them. We used to put open circles and then the line. So whether or not you see open circles or you see parentheses on the line, it's gonna mean the same thing. It means don't include -1 and 2 in your answer. So, but we know that those are the endpoints of the intervals. So we're gonna put our endpoints like that, and we're gonna use parentheses to show that we're not going to include that in our interval. Now this can look like coordinates, and but one of the main differences between coordinates and interval notation is that interval notation always goes from the lowest number to the greatest number. So you want to make sure that you always have that down. We're going to do this next interval. Once again, I'm going to just draw on it. If you see it in a different manner, you might see a closed circle on the 0 and an arrow going towards the negative infinity. So the negative infinity is going to be the left-hand side of that interval, and 0 is going to be the right-hand side. Now, we are going to include the 0 because it has a closed circle, or it has a bracket on it, so that's why we use the bracket to include the 0. But on the negative infinity, we never reach infinity, so we're going to use parentheses. That was sort of ugly. We're going to use parentheses to do that. Now, this is a half open, half closed interval. And we'll get some practice in questions 2 and 3. We're given an algebraic interval right here from -1 is less than x is less than 5. So we're asked to write each inequality using interval notation and graph each inequality on the number line. I'm actually going to do it out of order. I'm going to graph it first. So we're going to graph from -1. We're going to put an open circle or a parentheses, and at 5, we're going to put an open circle because those numbers are not part of it because these are not equal. And we're going to do the interval in between these two numbers. How would I write that in interval notation? Well, basically, we're going from -1 all the way to +5, and we're going to use parentheses for that open notation. For number 3, we have x is greater than or equal to -3. So on -3, we're going to put a circle and we're going to fill it in because it is equal to. And it's greater than, so we're going to go in the direction of greater than. And we're going to just keep on going. And the number, if it kept on going, it would keep on going to positive infinity. So those are the two numbers that are going to be on the end of our number interval. We're going to say it goes from -3 to positive infinity. Once again, -3 will be included in our interval. Positive infinity is not. So hopefully this little short review will help you as we move on to the rest of the questions where we're actually solving inequalities. We want to put all of our answers in interval notation. When you have answers like we had in previous sections, like an answer is 4, well, those, if you have a single answer, you're going to use set notation. If you have 2 answers, you're going to use set notation. But when you have an interval of answers, there's an infinite number of solutions here. We're going to use interval notation to denote that. So you have to make sure we understand the difference when we use interval notation and when should we use set notation. Alright, so we're moving on from doing the intervals, and we have some properties about inequalities to do. So the first property we have is the addition property, and it says for real numbers a, b, and c, if a is less than b, then you can add c to both sides and the inequality doesn't change. So then you get a plus c is less than b plus c. Likewise, if you have the statement if a is greater than b, then you can add c to both sides again, and you can get a plus c is greater than b plus c. It works the same way that the equal sign works in the addition. Now before we move on to the multiplication properties, I have a little bit that I want to show you. We have some statements that will be written like this: C is greater than 0. But when you read it out loud, you're not going to read it as greater than 0. Let me draw what this interval is on the number line. It's not including 0, and it's all these numbers over here. Those numbers are positive, so the way we would actually say this out loud is C is positive. Alright, the next one we have says C is greater than or equal to 0. Let's draw that on the number line. You would include the 0, and then you're going to have all the numbers over here. Now, we have a word for that in math. That word is the positives and 0, but we don't want to say that because that's too many words. So what we say is don't include the negatives. So we say C, So we say C is non-negative. And that means it includes the positives and 0. Alright, we also have a statement that looks like C is less than 0. So on the number line, that'd be an open circle at 0, and the arrow going this direction towards negative infinity. And when we say that out loud, we would say C is negative. And then we have the last one, which is C is less than or equal to 0. And when we say that out loud, well, when we put on the number line, we're going to include the 0, and we're going to go towards negative infinity. So the only numbers not in this set are positives. So we would say C is non-positive. And it might seem redundant. Why would I say non-negative instead of positive? Well, in math, it's not always a dichotomy. There's actually three things. If you're not negative, that doesn't mean you're positive. It means you're either positive or 0. So those are options that you have. You always have to remember that that 0 could or could not be in there, and you have to use language that's specific towards that. Alright, so the reason we had to go over those definitions of positive and negative is because instead of writing the words positive and negative, they just write C is greater than 0 or C is less than 0 in a lot of these definitions. So when we're talking about the multiplication property of inequalities, we have the statement here that says if A is less than B and C is positive, then we have AC is less than BC. And likewise, if we have A is greater than B and C is positive, then you have AC is greater than BC. In other words, the inequality symbol stays the same. You can see that it doesn't change direction, it stays the same. Or if it's greater than, then it's greater than. Alright, then next, if we have A is less than B and C is negative, then what happens when we multiply? Well, then the inequality symbol gets reversed. And so AC is greater than BC. And if A is greater than B and C is negative, then AC is less than BC. And you want to see that this inequality symbol, which started off as less than, turned into a greater than. And this one that was a greater than turned into a less than. So we have that rule that we can write in words, multiplying by a negative reverses the inequality. That was all very abstract and with letters and not very concrete. It's hard to grasp. So I just want to explain this in another way. If I asked you to put an inequality symbol between these two numbers, 1 and 5, which number is greater, 1 or 5? Well, you would say 1 is less than 5, and the greater one is 5. But if I asked you to do the same thing and say -1 and -5, which one is greater? oh, well, -1 is greater than -5. And so you can see that when you put negatives in front of the numbers, that inequality symbol switches. And that works anytime we change the signs. So let's try that one more time. Let's say -2 and -4. Which one is greater? Well, -2 is greater than -4. What if I change the signs? 2 and 4. Which one is greater? Oh, the 4 is greater than the 2. So you can see the signs changed again. We can do this again with one positive and one negative. -3 and +6. Which one is greater? Well, the positive number is greater. And so if I said +3 and -6, which one is greater? Well, it's going to be the positive number again. And so you can see anytime you switch the signs, or basically multiplying each of these inequalities by -1, the sign in between them switches. Now applying the rules that we just learned about the additive and multiplicative properties of inequalities, we're going to solve these next two inequalities. And so I'm going to subtract 5 from both sides. And I end up with 2x is greater than -4. And we keep the greater than symbol because we were using the additive property. Now I'm going to divide, and dividing falls under the multiplication property. And I'm dividing by a +2, so I'm not going to change the symbol. So we're still going to be greater than. Now I know my answer is negative, and we had a -4, but that doesn't matter. What matters is the number that we're dividing by. So the question says, express our answer in set notation. You're going to put your set, and it's going to say the set, which is all x's, such that they satisfy this statement. That's putting your answer in set notation. The other way they want us to express our notation is interval notation. So the interval notation would be going from -2 all the way to +infinity. So we're going to go -2, +infinity. We're not going to include the -2, and we never include the infinity. So there's our two answers, or two ways of expressing our answer, I should say. Moving on to the next problem, we're going to do the same thing. So let's go ahead and subtract 2 from both sides. Even though it's subtraction, that falls under the additive property. And so we're going to keep the symbol going the same way. Now I'm going to divide by the coefficient -3. And at this point, I am dividing by a negative, so I have to go ahead and change that symbol. I'm going to change that symbol first because it's so important. So anytime I write that dividing by negative, I'm going to change that symbol to be facing the other way around. So 3 divided by -3 is -1. And we're asked to do this in set notation. So I'm going to say the set of all x's such that the x's satisfy this statement. Or going from -1 to +infinity, and I'm going to include -1. Now if you're having trouble deciding which direction, if the -1 should be on the left side or the right side of the interval, one of the ways that we can figure that out is just to do a little quick graph. They didn't ask us to, but that can help. So you can say -1, we're going to put the closed circle on it. Which direction is that arrow going? It's going this way. Well, that's why I started my interval at -1 and ended at +infinity. And you always have to make sure you go in the correct direction. So you need to check that. At least mentally check if you're not going to put it on the paper. This next part isn't on your notes page, but I want to point it out, and it's talked about in the book. We have these reciprocal properties, meaning what happens if you turn a number into a fraction. Well, let's do an example first before we make up our rule. So, for example, if I said a number is positive, that's what this is saying. For example, 2. If 2 is positive, what's the reciprocal of 2? The reciprocal of 2 is 1/2. is that positive or did it become negative? It stayed positive. So we could say 1 over a is also positive. Alright. Now let's look at the next rule. If a is greater than b, so for example, let's look at some numbers where a is greater than b. Like if 5 is greater than 2, then what happens when I turn both of those into fractions? Which one is larger, 1/5 or 1/2? Okay, 1/2 is greater. Imagine if you had 1/2 of the pizza versus 1/5 of the pizza. So what happens when you make reciprocals? Look at that. The sign between them changes. So we'd say 1 over a is less than 1 over b. And these two rules might come in handy when you're solving equations. You might see fractions happen, and if we've never addressed this, you might be lost on, wait, hold on, which one's greater or less than. But now that we have these rules or these properties, it's helpful for us to apply to any other problems. The next 3 questions in our notes cover compound inequalities, and I rewrote the notes for the rules for compound inequalities. Basically, if you say a is less than x and x is less than b, you can combine those two statements to say a is less than x is less than b. So we're going to do that, and we're going to solve a compound inequality, and we've never really seen this with equations before. So I just want to come over here and say you have 2 inequality symbols separating this inequality into 3 sections. And whatever I do on one side, I have to do on all 3 sides. So just like we used to say, oh, add 2 to both sides of the equation, well, now I'm going to say subtract 2 from all 3 sides of this equation. So I'm going to move my constant away from the variable by subtracting 2 from all sides of the equation. I'm going to get 2 is less than or equal to 2x is less than or equal to 8. And then I'm going to divide by the coefficient of the variable. So I'm dividing by 2. Now, is that positive or negative? It's positive, so do my signs switch or do they stay? They are going to stay in the same direction because the 2 was positive. So when I do that division, 2 divided by 2 is 1. 2x divided by 2 is just x. And 8 divided by 2 is 4. And so there is my statement. I can write that in set notation as the set of all x's such that 1 is less than or equal to x is less than or equal to 4. Or I can write that in interval notation, saying that on the number line, 1 would be the left side and 4 would be the right side of the interval, and I would include them. Or there's my infinite number of solutions written in 2 different ways. Once again, doing the set notation way, then doing the interval notation way. For number 8, we are still doing compound inequalities. Now in this compound inequality, one of our sides, the middle side, it has a fraction in it. And we're going to still do the same thing that we did in prior questions, where we're going to say, what's the LCD? Now there's only one denominator, so that's the LCD. We're going to take the LCD and we're going to multiply all 3 terms by that LCD in order to cancel out that denominator. And so I'm going to be left with 0 is less than 3x plus 2 is less than 8. It looks like most of the equation didn't change. That's because you had a 2 times a 0, and then you had a 2 cancel out with that 2 in the denominator. And then we're going to go ahead and just do all the rest of the steps. So we're going to subtract 2 from both sides. We're going to get negative 2 is less than 3x is less than 6. We're now going to divide by the coefficient of the variable. So I'm dividing by 3. I end up with negative 2/3 is less than x is less than 2. I can write that in set notation by just saying the set of all x's that satisfy that rule that I have above. Negative 2/3 is less than x is less than 2. But we could also write it in interval notation, where we always start at the lowest number and we go up to the highest number in that interval. Because the symbol is less than, we're going to use parentheses. So there are all my solutions, all infinite number of solutions expressed in two different ways. Now for this last problem, the fraction in number 9 looks slightly different than the fraction in number 8. The denominator in number 8 was the entire denominator of the entire middle. Now that's not the case over here. So it just makes a slight difference, but we're still going to try to get rid of the fraction by multiplying by the LCD. We only have one denominator, so that denominator is 3. And so we're going to take all the terms, and that would be 4 terms. And we're going to multiply all 4 of them by 3. And when I multiply it out, I'm going to get 0 is less than 3 minus 1x is less than 3. I am going to subtract this 3 from all 3 sides. So I'm going to do that. Actually, let me just draw in my line so we can follow along. Alright. I'm going to get negative 3 is less than negative 1x is less than 0. Now in order to solve this, we're going to have to divide by the coefficient, which is negative 1. What do I do when I divide by negative? That's right. We're going to switch those symbols around. So I'm going to say put those that direction. This will become 3. This is going to stay as x. We leave that as 0. And it should always make sense. 3 has to be greater than 0 for this to make sense. So we want to write in set notation or interval notation. Now 3 is greater than 0, so we're going to put on this side of the interval. If you don't know which side, draw a number line and put it in order from left to right. Alright, so that's it for section 1.5. Thank you.